Okay, we resume. So let's get into some of the details now. So let's look at what we need to do to check the grid. And you'll see this is really, it's pretty simple. You just need to be careful. You just need to be very precise with it. So let's look at what we've got here. So here's just a little, a very small 2D array. So what is this? This is actually, so is this 4 by 4? No, it's actually, what is it? It's 5 by 5. Remember the indices start at 0. So here I have row 0, row 1, row 2, row 3, row 3, row 4, and here I have column 0, column 1, column 2, column 3, column 4. 2D arrays are said to be row major. What does that mean? Row major means when we refer to the indices in the 2D grid, just the indice or the index for the row comes first. So here, this first cell, this is row 0, column 0. This second cell, this is row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4. You get the picture. And the same is true all the way through. So for this little exercise, we're going to look at the cell at 2, 2. So it's the cell at row 2, column 2. Row 2, row major, column 2. Now, in this situation, how many neighbors? And this is the most common. This is the most common situation. A cell that's completely surrounded on all sides. I mean, it's not the most common situation in this small little grid, but in a big grid that's 100 by 100 or something like that, this is by far and away the most common situation. So, who are the neighbors of cell 2, 2? So cell 2, 2 actually has 8 different neighbors. So it's got a neighbor here at 1, 1, row 1, column 1, row 1, column 2, row 1, column 3. It's got a neighbor at 2, 1, a neighbor at 2, 3, and it's got a neighbor at 3, 1, 3, 2, 3, 3. Row 3, column 1, row 3, column 2, row 3, column 3. When you go to search in your nested loop, what you're going to want to do, so you're going to move through the grid a cell at a time. You're going to want to first check the neighbors in the preceding row. So if you're in row R, and for this example, row R is row 2. So if I'm in row 2, I want to check the state, alive or dead, of my neighbors in row 1. So here you can see I'm going to check 1, 1, 1, 2, 1, 3. How will I actually implement that? I'm going to check, in this case, I'm going to check row R minus 1. So that's row 1, and I'm going to check the cell in C minus 1. So remember I was in 2, 2. I'm going to begin by checking the cell at R minus 1, C minus 1. 2 minus 1, 2 minus 1. I'm going to check the cell at 1, 1. I'm going to continue, and you can see I'm moving down this list on the right side of the view of the slide here. I'm going to continue in the row immediately preceding. So I'm going to continue in row R minus 1, but now I'm going to check column C. Remember we were in row column 2, 2, so I'm going to check row 1, column 2. That's this cell right here. Next I'm going to check row 1, column 3. So that's row R minus 1, C plus 1, or cell 1, 3. I'm going to move to the next row because none of these other cells are neighbors. I'm not interested in them right now. So now I'm going to move down to row R. The one we just did, we checked the neighbors in row R minus 1. Now we're going to check the neighbors in row R. I'm going to check row R, cell in row R, column C minus 1. So that's this cell right here, row 2, column 1. I'm not going to check myself. I'm going to skip over the cell of interest. But then I'm going to check the cell immediately to its right. That's row 2, row R, column 3, or column C plus 1. So that's 2, 3. So I think you're starting to see how this works. Let's continue. Final check. Remember, I started, so I checked row R minus 1. Then I checked row R. Now what are we going to check? Yes, of course, row R plus 1. So let's look here. Row R plus 1 is row 3. I'm going to check R plus 1, C minus 1. That's 3, 1. I'm going to check R plus 1, column C. That's 3, 2. That's this cell right here. Now I'm going to check row R plus 1, row C plus 1. That's row 3, column 3. And I'm done. So in this case, for a cell that's completely surrounded on all sides, there are 8 possible neighbors. Now, what did I do when I was moving through, starting with row R minus 1, row R plus 1? I'm keeping count of what? The number of live neighbors. And you can see once I've done this, the rest sort of falls out. I have a count, call it neighbor count or something. And based on the number of neighbors that I've counted, I can directly apply the rules. The birth rule, the sort of steady state rule, stays alive, or the loneliness and overcrowding rule. So this is sort of a happy day case. Special cases are the corners and edges. And corners and edges, if you try, for example, if we try to apply this strategy here, let's look at cell 0, 0. What would happen right away? This is R equals 0, C equals 0. Right away, I get an exception. If I tried R minus 1, C minus 1, both, in this case, both of the indices are out of bounds. I'd be trying to check row minus 1, column minus 1, neither of which exists. Now, that said, as you work through this, you will get array index out of bounds exceptions. Everyone does. It's just the nature of this kind of work. It might take you a couple times. That's okay. That's actually pretty normal. It's pretty normal for it to take you a couple times. So don't feel daunted in any way if you get array index out of bounds. Everyone does. So here's sort of the happy case. Let's continue. Okay. Let's say before we get into some of the other stuff, let's just say a quick word about two-dimensional arrays, because you need to have some facility with 2D arrays to do this work. So I think we all know and I think we all know all of this. So this is just a quick quick review. A one-dimensional array stores what? A list of elements of the same type. A 2D array, look at it as a table, just as we've been talking, a table of elements with rows and columns. So there's the one-dimensional array, pretty straightforward. There is the 2D array. So rows, columns, and remember we're row major. So the index, when you're specifying the indices, the index of the row comes first. So as we do this, let's apply what we know about 2D arrays, and let's go ahead and check for edges. And here's a little bit slightly trickier case. So we'll do that in the very next video. We'll continue here with check for edges.